Hello students, welcome back to Pros and Experts, the tutorial video series on signals and systems, KTU solved questions. So we will start with part C of the KTU syllabus, and in this part we will cover all the tutorial questions from the topics discrete term Fourier series, discrete term Fourier transform, and Z transform. So remember, a large weightage of the total questions marks will be from this part, so be very attentive on solving the questions. So let's start solving the first question. Find the Z transform of x of n equal to 2 into 3 to the power n u of minus n. So this question is to find out the Z transform, and the given signal is 2 into 3 raised to n u of minus n. On a single look, what we have to imbibe is nothing but the most important point is this signal is a left-sided signal. Why it is a left-sided signal? Because there is a u of minus n term here. Because signal is multiplied with u of minus n means only samples in the negative time axis, right? Negative x-axis will be valid. So this is a left-sided signal. Okay. So whatever be the signal, let us start from the scratch. We know the definition of Z transform. Z transform of any discrete time signal x of n is given by x of z equal to sigma n equal to minus infinity to plus infinity signal into z raised to minus n. This is the definition for Z transform. You know it. Okay. So in this signal, in the given particular signal, there is no any samples in the positive time axis, right? In the positive time axis means if you are taking n, now this is discrete time signal, so the x-axis is n. So the signal is having values only on positive n axis if the signal is right-sided, okay? But given signal is something in the u of minus n, that means this is not the case. The signal is having samples only in the negative n axis, okay, negative n axis, okay, from 0 to minus 1, minus 2, minus 3, etc. up to minus infinity, signal will be having values. All right, so let us keeping this in mind, let us attempt to find the Z transform of the signal. So from the definition given in this equation, how will you proceed? It is very simple, because the summation exists only from n equal to 0 to minus infinity, right? N equal to 0 to minus infinity. X of n is given in the question as 2 into 3 to the power n, and u of minus n is not needed. Why? Because as a result of the presence of u of minus n, I have truncated the signal, the summation, from only in the negative n axis. Okay, I have truncated all the positive n values, so no need to write u of minus n further, because its amplitude is 1 in this particular interval. Okay, so this is equal to 2 is a constant, so I can take it outside the summation. So n equal to 0 to minus infinity, 3 raised to n. Okay, there is a 0 raised to minus n here, because in the definition 0 raised to minus n is there, x of n into 0 raised to minus n. So x of n, that is 2 into 3 raised to n into 0 raised to minus n is there. So 2 into 3 raised to n, 0 raised to minus n. Okay, or I can write it as 2 into sigma n equal to 0 to minus infinity 3z inverse the whole raised to n. That is also right. Okay. Now there is nothing left behind us except expanding this summation, right? We can expand this summation by putting n equal to 0. Then what is the next n value? Is it 1? No, you have to be very attentive that we have truncated all the positive n values. So the signal exists only in the negative time axis. So n equal to 0, then comes n equal to minus 1, then n equal to minus 2, and it goes up to minus infinity. So when you put n equal to 0, you will get 3z inverse whole raised to 0, which is 1. Okay. Now what happens when you put n equal to minus 1, the second term in the summation? That means it is 3z inverse to the power minus 1. Then n equal to minus 2 means it is 3z inverse to the power minus 2, and it goes on to infinity. It goes on to minus infinity actually, right? Minus infinity. Okay. Now that is equal to 2 into, can you determine what kind of a sequence you are encountering? 1, then 3z inverse whole inverse, 3z inverse whole inverse 2, and goes on. This is nothing but a GP, geometric progression, with first term is equal to, with first term a equal to 1. And what is the next property of interest? It is common ratio. What is common ratio? Common ratio is 3z inverse to the power minus 1, or that is 1 by 3z inverse. That is the common ratio. And remember, the sum of such an infinite GP is given by S is equal to A by 1 minus R. And you have to be particularly attentive, because this equation can be taken only if mod R is less than 1. Only if the common ratio is less than 1. It's a fraction less than 1. Okay. Now let us continue our simplification. So this is A by 1 minus R. A is 1 first term, divided by 1 minus, what is R? R is equal to 1 by 3z inverse. R is actually equal to 3z inverse whole inverse, that is 1 by 3 inverse. 1 by 3z inverse. Okay. That is equal to 2 into, you can always find the LCM. So 1 by 3z inverse minus 1 whole divided by 3z inverse, or I can take that 3z inverse to the numerator. So 3z inverse by 3z inverse minus 1, or that is equal to 2 into, I can divide by 3z inverse whole. So 1 by 1 minus 1 by 3z inverse, right? 1 by 3z inverse. And what will become to z inverse? I can write z inverse in the numerator, immediate numerator. So this is 2 into 1 by 1 minus z by 3. That is the Z transform. But always remember, whenever you refer to Z transform or Laplace transform, you have to be very careful about one more thing. The Z transform or Laplace transform as such is not enough, but the region of convergence is also important. So what is the region of convergence here? In order to find a region of convergence, what you have to do is, we have purposefully mentioned an assumption here to validate this equation. Only through this equation we came at this result, right? So the role of this equation, this result, is very crucial in this problem, and this equation is valid only if mod R is less than 1, the common ratio is less than 1. So we have to be very noting of that equation. So mod R should be less than 1. So this is valid only if mod R is less than 1. If, what is R? R is equal to 1 by 3z inverse. Okay, so mod of 1 by 3z inverse is less than 1. This is valid only if Z transform, this expression as Z transform is valid only if mod 1 by 3z inverse is less than 1. That implies 1 less than mod 3z inverse. Okay, and what does that say? That implies 1 less than mod 3 by z. Okay, or that implies mod z, you can take z here. Okay, mod z less than 3. So mod z less than 3 is the ROC of this Z transform given by 2 into 1 by 1 minus z by 3. The next question is, compute the DTFT. DTFT means discrete term Fourier transform of the signal x of n, and x of n is given. Okay, so let's have first a look at the signal x of n equal to 10 for mod n less than or equal to capital N, and 0 for mod n greater than n. It would be very good if you have a pictorial intuition to the signal. Let me help you for that. Let me roughly plot the signal. So x of n is equal to 10 for mod n less than or equal to n. So whatever be n, there will be minus n and plus n. So x of n is amplitude 10, right? X of n is amplitude 10 for mod n less than or equal to capital N. So this will be something like that. Okay, this is n equal to 0, 1, 2, etc. goes to n. This is minus 1, minus 2, etc. goes to minus n. And all these samples are 10, amplitude 10. And all other samples are 0. Okay, why? Because mod n greater than n means mod n, I can always write mod n greater than n as n greater than plus n and n less than minus n. Is that correct? 0 for mod n greater than n means 0 for n greater than positive n. This is n greater than positive n. So all samples are 0. Similarly, n less than minus n. So 0 for all n less than minus n. That means this portion. Okay. And 10 for mod n less than n. Right? Mod n less than n means I can write mod n less than n as n less than plus n and n greater than minus n. So what is n greater than minus n? This is the point, n greater than minus n. Okay, so in that case sample is 10, and for n less than plus n means this portion, n less than plus n means this portion. There also amplitude is 1. Okay, so that's an intuition to the signal, how the signal occurs, right? Now we have to find out the DTFT, and DTFT is given by x of e raised to j omega is equal to sigma over n equal to minus infinity to plus infinity x of n e raised to minus j omega n. This is the expression to find out DTFT. Very similar to CTFT, but here the signal is discrete. Okay. All right, let's start doing this. So this is equal to, I can always split the given signal x of n into two parts. Very simple. One from minus 1, minus 2, etc. up to minus n, negative time, and other n equal to 0, 1, 2, etc. plus n, that is in the positive n. So we can split this signal into two different parts. So accordingly, I am rewriting my summation as n equal to minus n to minus 1, right? N equal to minus n to minus 1 means this much samples in the negative, pure negative n axis. Okay, in that case the amplitude is 10. So 10 e raised to minus j omega n. I have to write e raised to minus j omega n also. Plus, this is not over. We have to include the other samples also. The other samples are in positive n. So 10 into, or sigma is n equal to, what is the limits? In the previous case, we have taken minus 1 to minus n. That means minus 1 including to minus n. So now we have to take 0, 1, 2, etc. up to plus n. So n equal to 0, 1, 2, etc. up to plus n. Okay. Then x of n is 10. Again 10 into e raised to minus j omega n. Okay. Okay. Now what can we do? Now the only option left behind us is expand the summation, right? We have two sigma terms, so expand sigma. So while you expand sigma over the first term, that means this term, what happens is, first we can I can also change this limits from minus n to minus 1 to minus 1 to minus n also. Okay, I think you're getting what I'm implying. N equal to minus 1 to minus n is also valid because summation is commutative. So summating from minus 1 to minus n backwards is same as summating from backwards minus n to front minus 1. There is no difference. So I can write as n equal to minus 1 to minus n. So when you expand the summation, first value you have to put at n as -1. So what happens? e raised to minus j omega into n equal to actually -1, right? -1. So what happens? It is e raised to plus j omega. Okay, so I can save one step and save time. So e raised to plus j omega. This is for n equal to -1. And what happens to the term when you put n equal to -2? It becomes e raised to plus j omega 2. Is that right? Because we are putting n equal to -2 here. N equal to -1. After that, n equal to -2. Okay, so n equal to -2. When you put n equal to -2 here, it is e raised to plus j omega 2. Right. Then the next term would be e raised to plus j omega 3, and so on goes to, what is the last term? Is it going to infinity? No. The summation is from -1 to -n. So the final value will be e raised to plus j omega n. Okay. Plus, there is one more term, right? One more sigma term, which on expansion will give you here the difference is the summation starts from n equal to 0. Okay, so the first n value you have to put here as 0. That means 10 e raised to 0 is 1. So there is a 1 here. Then n equal to 1. Next is n equal to 1. This is in the positive n axis. Okay, so n equal to 1 means e raised to minus j omega plus e raised to minus j omega 2 plus etc. up to e raised to minus j omega n. Okay, because n is the last value. All right. Now what we are going to do is, this is equal to 10 into, if you are so experienced in linear algebra, then we can find out that this sequence is nothing but a geometric progression, right? But this time this is not an infinite GP, this is a finite GP. And what is the expression for sum of finite GP? It is a into 1 minus r raised to n by 1 minus r. This is a sum of n terms of a GP. Okay. So what is the first term of this GP? A. What is the first term? A is e raised to j omega. What is the common ratio r? Common ratio r is again e raised to j omega, because e raised to j omega 2 divided by previous term e raised to j omega gives you e raised to j omega itself. So r is equal to e raised to j omega. Okay. So I can expand it as, first term is e raised to j omega. First term is e raised to j omega. I'm implying this equation. Okay, a into means e raised to j omega into 1 minus r. R is e raised to j omega itself whole raised to n. Right? N means it is the number of terms. N means number of terms in this GP. How many terms does this GP has? E raised to 1 j omega, e raised to 2 j omega, e raised to 3 j omega, etc. e raised to n j omega. That means you can have n terms here, right? N terms here, right? 1, 2, 3, etc. n terms clearly. So I can write 1 minus e raised to j omega to the power n. Okay. Then divide by 1 minus r is there. So divide by 1 minus e raised to j omega. Okay. This is the first term. Similarly, we have a second term. That is also, if you observe very carefully, this is also a GP. Again, it is a finite GP, not infinite. It's a finite GP. So again, you can use this expression to find out the sum, which is a into a is 1 minus r. R is, what is r? R is e raised to minus j omega. Here r is e raised to minus j omega. Why? Because if you divide e raised to minus j omega with the previous term, you will get e raised to minus j omega itself. So that is the common ratio, e raised to minus j omega. Okay. Now what is the number of terms? We have n here. What is the number of terms? Is it n? It is not n, because e raised to minus 1 minus j omega. Okay, it is e raised to minus j into 1 omega, 2 omega, etc. n omega. So these terms are n in number, and additionally there is a 1 here. So n plus 1. Okay, n plus 1 terms are there in this GP. Okay, so total number of terms is n plus 1 whole divided by 1 minus r means 1 minus e raised to minus j omega. Okay, so this is 10 e raised to j omega by 1 minus e raised to j omega into 1 minus e raised to j omega n plus 10 by 1 minus e raised to minus j omega into 1 minus e raised to minus j omega into n plus 1, right? So this is the final answer. If you want, you can still simplify this expression, okay, but this is only a 4 marks question, you can see, so we can stop here. Okay, all right, the next question is, prove that for a bibostable discrete time LTI system, the ROC of the system function includes the unit circle. So the question asks you to prove that for a stable system, bibostable system, it is a discrete time system, its ROC, when you find the Z transform of that system or transfer function of that system, its ROC should include the unit circle. Okay, that means a stable system will be having an ROC which includes the unit circle. So let's start from the basics. In the initial modules, we have studied that for a bibostable system, the impulse response will be absolutely summable. H of n will be absolutely summable. That's what we know. Absolutely summable. Okay, that means sigma over n equal to minus infinity to plus infinity, h of n, right? That will be a finite value. This is what we know. This is for a bibostable system. Okay. Okay, now let us step onto the transfer function. In a discrete time system, the transfer function is expressed using Z transform, and you know it is given by h of z is equal to sigma over n equal to minus infinity to infinity h of n z raised to minus n. This is a transfer function. Transfer function is nothing but finding the Z transform of impulse response. You know, impulse response is h of n. Finding the Z transform of h of n will give you h of z, and that's what you can see in this equation, right? Okay, now let me find the absolute value. Absolute value of mod h of z will be equal to absolute value of sigma of absolute value of h of n 0 to minus n. Okay, and that is less than, you know, that's less than sigma n equal to minus infinity infinity mod h of n into mod 0 to minus n. Okay, you call this Schwarz inequality, using Schwarz inequality. Okay, so the total modulus will be less than or equal to the modulus of individual products. All right, now let me assume that this Z transform includes, or this Z transform is stable, or Z transform ROC includes the unit circle. That's what we are asked in the question. So let the ROC includes unit circle. That means, what is the speciality of unit circle? Unit circle means it will be having the radius or modulus mod z is equal to 1. Mod z equal to 1 is the expression for unit circle. Why? Because we know z equal to r e raised to j omega, right? R e raised to j omega. If at all it is unit circle, r will be equal to 1, right? R will be equal to 1 because radius is 1, and if r equal to 1, r is also the modulus of this complex number, right? Z equal to r e raised to j omega is the polar form of a complex number, you know that. So if r equal to 1, that means the magnitude of this complex number is equal to 1. Okay, so I can put mod z is equal to 1 in this equation. That means mod h of z will be less than or equal to sigma n equal to minus infinity to infinity mod h of n into 1 raised to minus n. 1 raised to minus n is nothing but 1 itself. Okay, all right. And now from this equation, right, this equation, it is clear that this is less than infinity, so the system is stable. So we can conclude that for a before stable system, the ROC of the Z transform includes unit circle, and hence the proof. Okay, the next question is, an LTI system is described by the following input-output relation. You're given a difference equation. Determine the impulse response of the system with the specified ROCs of h of z for the conditions. First condition is system is stable. Next is system is causal. See, this type of questions are very, very important. Very, very important. So you must be very attentive. Okay. So initially we are given a difference equation, and you have to find out h of z. Okay, that's very simple. So let's do that. So applying z transform on both sides of a difference equation, we can get y of z minus 9 by 4. What is the z transform of y of n minus 1? It is z raised to minus 1 into y of z. It's made using the time shift property of z transform, plus half z raised to minus 2 y of z, again using time shift property of z transform, equal to, on RHS, upon applying z transform, x of z minus 3 into z inverse into x of z. Okay, now let me take y of z common in LHS and x of z common in RHS. So y of z into 1 minus 9 by 4 z inverse plus half z inverse 2, that becomes equal to x of z into 1 minus 3 z inverse. And what you need to find is h of z. H of z is nothing but y of z by x of z, right? Transfer function is output transform by input transform at 0 initial conditions. So I can directly write h of z is equal to y of z by x of z will be equal to 1 minus 3 z inverse whole divided by 1 minus 9 by 4 z inverse plus 1 by 2 z inverse 2. Right. Now our aim is to find out h of n. They have given us two conditions. First condition, you find h of n assuming that system is stable. Second, you find h of n assuming that the system is causal. All right. So before finding h of n, what is the procedure to find out h of n? It is to find out the partial fractions, or make this expression into partial fraction. You don't have to worry about the numerator, let it be so. But what about denominator? It is not in factor form, it is in a polynomial form. So what we have to do is first make it into a factor form. So factorize this, the denominator alone. So how can you factorize 1 minus 9 by 4 z inverse plus half z inverse 2? It is very similar to how we have factorized in the case of Laplace transform, right? If it is s square minus a plus b into s plus ab, or s square plus a plus b s into ab, what we have assumed is this term or this coefficient is the sum of the factors, right? And this term, this term is the product, right? So our aim is to find out two numbers, two constants whose sum is 9 by 4 minus 9 by 4, and the product is 1 by 2. Okay, so I can get two such numbers as minus 2 and what can be minus 1 by 4, not plus 1 by 4, minus 1 by 4, right? So minus 2 minus 1 by 4 will give you minus 9 by 4, this thing, and minus 2 into minus 1 by 4 will give you plus 1 by 2, so this thing. So our factors are ready. So I can write 1 minus 2z inverse into 1 minus 1 by 4 z inverse. This is how you can factorize this polynomial into z transform form. Okay. Now we can put it as partial fractions. A by 1 minus 2 z inverse plus b by 1 minus 1 by 4 z inverse. Okay, and how will you find out a? This is equal to for a what we do is you find what value of z makes the denominator to 0. Okay, then multiply this whole fraction with the denominator. Okay, with the denominator. So what happens is a is you can write something here. Okay, a is equal to, you multiply this fraction with this factor, so this factor will be gone, and so 1 minus 3 z inverse by 1 minus 1 by 4 z inverse at z inverse equal to, that's the question, that's a big question. For what value of z inverse, at what value of z inverse? Look at this fraction. For z inverse equal to 1 by 2, if I give z inverse as 1 by 2, z inverse as 1 by 2, this denominator will become 0. Okay, so at z inverse is equal to 1 by 2, and what will be the value? That is equal to 1 minus 3 into 1 by 2 by 1 minus 1 by 4 into 1 by 2 is 1 by 8. So this is 1 minus 3 by 2 is minus 1 by 2 divided by 8 minus 1 by 8 is 7 by 8. And that will give you, this is 4, that is minus 4 by 7. So a is equal to minus 4 by 7. So you can write minus 4 by 7 divided by 1 minus 2z inverse. Plus, similarly, in a similar fashion, you can find out b. How can you find out b? What is the denominator of b? Under b, it is 1 minus 1 by 4 z inverse. And so what you have to do is, you take this factor, multiply that factor with the whole transfer function. So this 1 minus 1 by 4 z inverse cancel out. And so I can write b equal to 1 minus 1 by 4 z inverse cancel out. So 1 minus 3 z inverse by 1 minus 2 z inverse at z inverse equal to, what is the value of z inverse? At z inverse equal to, look at this term. When z inverse equal to 4, the denominator vanishes, right? So z inverse equal to 4. So what happens? Is this equal to 1 minus 3 into 4 divided by 1 minus 2 into 4. So this is 1 minus 12 is minus 11 by 1 minus 8 is minus 7. So it is plus 11 by 7. So the value of b is plus 11 by 7. So 11 by 7 divided by 1 minus 1 by 4 z inverse. So we have got the h of z in partial fraction form like this. Okay, now we have to find out h of n for the first condition where h of n, or the system is stable. Not h of n, the system is stable. So for the stable system, you know, immediately think what you know. For a stable system, the ROC of Z transform contains the unit circle. Okay, contains the unit circle. So let us now draw the ROC of the Z transform. ROC of this Z transform. So it's very simple to draw the ROC of the Z transform. And how to draw the ROC of Z transform? You know, this term alone will be having a Z transform. This term alone is a Z transform, and this term has its own ROC. This term has its own another ROC. But what is the ROC of the whole term? It will be the intersection or the common area intersection of the two individual ROCs. So let me first draw the ROC Let me first draw the ROCs. What is the ROC of this term alone? It is ROC is mod Z, or before that, what is the pole in this expression, this term alone? Pole will be equal to Z equal to 2, right? Z equal to 2. So I am marking Z equal to 2 somewhere here. Okay, and I am drawing a circle. Drawing a circle with radius 2. Okay. Now, what is the pole comparing to this term? It is Z inverse equal to or Z equal to 1 by 4, right? Z equal to 1 by 4. Remember, whatever you find the coefficient of Z inverse will be the pole. Here is Z equal to 2. Here Z inverse, the coefficient is 1 by 4. The pole is 1 by 4. Okay. So we got Z equal to 2 and Z equal to 1 by 4. So I am drawing another circle. Okay, another circle with the radius 1 by 4. 1 by 4 will be somewhere here. Okay. Let me assume it is somewhere here. 1 by 4. So let me draw circle with the radius 1 by 4. Okay. And also let me draw the unit circle. Unit circle will be somewhere here. Sorry. Okay, unit circle. Let me represent this white circle as unit circle. Okay. Now, before elaborating the solution, let me also give you the individual ROCs. We have two individual terms. Let me take individual ROCs. So, first term minus 4 by 7 by 1 minus 2 Z inverse. The pole is at Z equal to 2. Okay. So the first circle, first yellow, the bigger circle is for Z equal to 2. So, right, and the second term is 1 minus 1 by 4 Z inverse. So I'm drawing separate circle for 1 by 4. Okay. So what are the possibilities of ROCs for the total term, this term? One possibility is both the ROCs, I mean both the impulse response will be right-sided, causal. That means you can have an ROC for this term alone, this individual term like this, and this individual term like this. So what will be the intersection of these two ROCs? It will be mod Z greater than 2. That means this section, right? Okay, this is a possibility. Okay, it extends to infinity. This is a possibility. And if you choose this possibility, could you get the answer? Does this ROC include the unit circle? No, it does not. Okay, so we can rule out this possibility. This is not possible. All right. So the next possibility I am taking is the ROC can be like this. Individual ROC can be like this. The ROC is inwards to the circle for this term, for the term with pole 2, like this, and for the pole with 1 by 4, the ROC can be outer to the circle, right? Now what is the intersection? The intersection will be, there is ROC for region greater than 1 by 4, but ROC is region less to 2. So this will be the ROC. Okay, this will be the ROC, or in mathematical terms we can say 1 by 4 less than mod Z less than 2. Okay, this is a possible ROC. that means 1 by 4 less than mod z less than 2. So in this case, does the ROC touch the unit circle? Yes, now the ROC touches the unit circle. Okay, so this can be a possible answer. So we can write down the inverse transform as, what is the specialty of this ROC? Here, for the pole 1 by 4, ROC is external, right? To the rightmost pole. That means the signal corresponding to this pole will be causal or right-sided, because the ROC is right-sided. ROC is right-sided. So the signal corresponding to pole 1 by 4 is right-sided. That means this term. So the inverse transform, I can write h of n equal to inverse transform of that pole, that is 11 by 7 by 1 minus 1 by 4 z inverse will be right-sided signal. So I can write it as 11 by 7 into, what is the inverse transform of 1 by 1 minus 1 by 4 z inverse? It is 1 by 4 raised to n u of n. 1 by 4 raised to n u of n. Okay. Now, what is the state for this term? This term has pole 2. That means this one. Here, the ROC is inner to the inward circle, right? Inwards. So, or the ROC is left-sided, right? That means the signal, while you find out the inverse transform, the signal corresponding to this term will be left-sided, not right-sided. It is left-sided. In this case, it was right-sided because the ROC is outer. But in this case, the signal is left-sided because ROC is inwards. Okay. So how can you write down the inverse transform for this term? It is, you have to put a negative. So negative of negative 4 by 7 becomes plus 4 by 7 into 2 raised to n into u of minus n minus 1. Okay. So let me write a bit clearly. Therefore, h of n is equal to the first term corresponding to this term is the first signal corresponding to this term is left-sided. So minus of minus 4 by 7 is plus 4 by 7 into 2 raised to n. To make it left-sided, u of minus n minus 1 should be added, plus the second term should be right-sided corresponding to this term. So right-sided. Therefore, no need of any change. 11 by 7 into 1 by 4 to the power n, and since it is right-sided, it is u of n. Okay, so this is the impulse response when the system is stable. Okay. Now, secondly, the question has asked such that find the impulse response such that system is causal. System is causal. Its answer is already we have discussed. Anyway, so let me once again plot the Z transform ROC. So this corresponds to 1 by 4. 2. Pole 2. This is for 1 by 4, and this is our unit circle. And now the system is causal. For the system should be causal, you know what you have to remember is, so for the system is causal, the ROC should be right to the rightmost pole. Right to the rightmost pole. And which is the rightmost pole here? It is 2. So the ROC, entire ROC should be right to the rightmost pole in this fashion. Okay. Outer to the outermost circle. Outermost circle which corresponds to the outermost pole. Okay. So this goes to infinity. This is the ROC. For determining the ROC of the such an ROC, we have already discussed that the entire ROC should be right to the rightmost pole. For that, the individual ROC should be right-sided. Okay, if at all the individual ROCs for pole 2, the ROC should be like this, and for pole 1 by 4, the ROC should be like this. Then only the intersection will be like this. This should be ROC. So both the signal correspond to both the poles should be right-sided. Therefore, we can write h of n as both the terms should be right-sided. So minus 4 by 7 into 2 raised to n u of n plus 11 by 7 into 1 by 4 to the power n u of n. Okay, so So this is the impulse response for the second state, second question. So that's the answer to the question. But still, if you have any doubt, I'm consolidating what I have given. For the first case, for stable system, ROC should be including the unit circle. Okay, so I'm drawing vaguely. So 1/4 and 2. So here it is the unit circle. Here comes the unit circle. So for the ROC to include unit circle, the individual ROC should be like this. For pole 2, the ROC should be inner to the circle. Okay, and for pole 1/4, the ROC should be outer to the circle. Okay, like this. Then only the intersection will be having this region, right? This region, and that region has unit circle. Okay, that is possible only when the signal corresponding to pole 2 is left sided and signal corresponding to pole 1/4 is right sided. So you write accordingly. And in the second case, for causal, what we know is the individual ROCs, circle corresponding to individual poles. This is 1/4, this is 2. So the total ROC should be like this, outer to the outermost pole. That's for causal signal. You have to study that. Okay, and for individual ROC, the intersection of the individual ROC to be occurring like this, you need to take the individual ROC of 1/4 as outer to the circle, and for the pole also outer to the circle. Then only the intersection comes like this thing. Okay, so both the signals corresponding to both the terms are right sided. Okay.